Hello children. Loci as the term goes, locus. Plural loci, singular locus. It's a path traced by a moving object which fulfills a given condition. Locus is a path traced by a moving object which fulfills a given condition. For example, the locus of points equidistant from two fixed points is the perpendicular bisector. The locus is the perpendicular bisector of this line. Perpendicular and bisector of this line because it's equidistant. Any point you take over here is equidistant. Distance is the same. This distance is equal to this distance. It's always equal. This distance equal to this. This is equal to this, and so on. That's one locus. Another locus is, children, locus of point equidistant from two intersecting lines. Intersecting lines, children, the locus would be the angle bisector. The angle is bisector. So if I take any point, children, these two are perpendicular and this angle is bisected. But the locus can be here or here. For angle bisected, it can be on this side or this side. Both are loci, children. Both are loci. Locus of point at a fixed distance from a fixed point. Locus of point at a fixed distance from a fixed point like this. It'll be a circle at a fixed distance from a fixed point. Locus of a stone dropped from a tower, vertical. Locus of a point equidistant from a fixed line. So it can be like a distance of 2 centimeters from this line up or 2 centimeters down. Locus of midpoints of locus of point equidistant from two parallel lines would be this line, which is parallel midway between the two. There are different loci, children. Let's see a few sums based on it now. Question says, construct a parallelogram ABCD. Locate point P on DC. On DC, which is equidistant from AB and AC. From AB and AC. So here, children, a rough diagram for this would come out to be AB, BC, CD. AB is 5.1 centimeters, AC is 5.6, BD is 7 centimeters. Point P on DC, which is equidistant from AB and AC. So the locus of that is an angle bisector, children. You get the angle bisector wherever it meets. So children, to first construct the parallelogram, we will draw the base AB, mark 5.1 centimeters, then half of 7 is 3.5 we'll mark, and half of this is 2.8 we'll mark, children, and then we'll mark it again, extend the line. So that's this line extended, this line extended. And then, children, take this measurement mark, take this measurement mark to give you the parallelogram. And D, and this is the point P. Now, children, to get the angle bisector of this, the angle bisectors will be cut an arc, then keep here and cut, keep here and cut, and then join it. This is the point that they need, which is equidistant, children. Since that's angle bisector, it's equidistant from AB and AC, and it's on BC, which is what they wanted, children. Let's see another example. Question says, ABCD is a rectangular park. ABCD is a rectangular park. So, children, there is rectangle. Let's construct as we these rough diagram as we write the question. A fountain has to be located in it at a place. A fountain has to be located in it at a place which is equidistant from AB and AC. From AB and AC. Also equidistant from DNC. Find the location of the fountain. So children, the fountain dimensions can be taken as any that you want. It's equidistant from AB and AC, so we'll first connect AC, and then to get it equidistant we'll do the angle bisector. Also equidistant from D and C. So children, if it's equidistant from D and C, we'll have to do perpendicular bisector of that. So from here cut, that's perpendicular bisector. Wherever it meets, this is your point where the fountain will be located. That's point P. Now for construction, children, what we'll do is we'll take AB as 8 centimeters, any length but 8 centimeters, and then construct two perpendiculars over here. That's 60, 120, and then 90. Same way over here, children, it'll be 60, 120, and 90. And then we mark the height as around 5 centimeters and connect it. Now children, we'll draw AC, that's this line. And now we'll construct the angle bisector, that's mark and then cut to give us the angle bisector. And now children, it's equidistant from D and C, so we'll do perpendicular bisector of that. So it's like an arc, mark, and then here mark. This children, where the two loci meet, this is where the point the fountain would be located. This is the point P where the fountain will be located, which is equidistant from AB and AC, also equidistant from D and C. Let's see another example, children. Draw a circle radius 4 centimeters. Mark two chords AB and AC. Of length 6 and 5 centimeters. 6 centimeter and 5 centimeter respectively. Construct locus of points inside circle which are equidistant from A and C. Also, construct locus of point inside circle which are equidistant from AB and AC. That's So children, a rough diagram for this would be a circle 4 centimeters. Then you have to mark two chords, AB 4 centimeters, 6 centimeters, and AC 5 centimeters. So it will be somewhat over here. It will be over here, children. This will be the line AC. Now, look at the point equation from A and C, children, will be the perpendicular bisector of AC. So that's the perpendicular bisector. That's one locus. And then construct locus of point equation from AB and AC to angle bisector, children. The angle bisector, and where they meet is the point P, is the second locus. To construct the children, first we'll draw the radius of 4 centimeters, circle of radius 4 centimeters. Once you've drawn that, children, we'll take any point A, this point is A, and then from here we'll mark 6 centimeters, and here we'll mark 5 centimeters, and we'll connect it. And then children, first locus is locus of point equation from A and C. This is B, this is C. So we'll do perpendicular bisector. So keep here, mark and mark, keep here, mark and mark, and connect it, children. Now children, let's say locus of point equidistant from AB and AC, which is the perpendicular, which is the angle bisector, children. So we'll mark the arc, and then from here we'll cut, and then from here we'll cut and draw the angle bisector. Once we get the angle bisector, children, this is locus 1, this is locus 2, and this is the point P of intersection of both of these. This is another question, children. Construct triangle ABC in which AB equal to 5 centimeters, BC equal to 8 centimeters, angle ABC equal to 60 degrees. Construct locus of points equidistant from AB and AC. So the locus of point equidistant from B and C. Mark the intersection as point P. Now children, what we have is this triangle ABC, rough diagram first. That's A, B and C, with AB being 5 centimeters, BC being 8 centimeters, this being 60 degrees. Locus of point equidistant from AB and BC. When you say equidistant from AB and BC, children, will be the angle bisector. That's 30 degrees. Locus of point equidistant from B and C, children, would be the perpendicular bisector. So you draw perpendicular bisector, and where they meet, this point is point P. Now the proper construction, children, we draw AB 5 centimeters. That's AB 5 centimeters. Then we construct angle 60 degrees. That's 60 degrees, 120, and then we join this line, and then we mark 8 centimeters. Once we mark 8 centimeters, we get point C and we connect it, children. Connect this. Once we have this, children, they ask for locus of point equidistant from B and C. AB and BC. AB and BC will be the angle bisector. So from here we'll mark, and from here we'll mark. This angle would come out to be 30 degrees, children, the angle bisector. Then this equidistant from B and C. We mark here and here and here and here, and then we do This point, children, this point comes out to be P, because it's equidistant from B and C and also equidistant from BC and AB. This is the point region. This is what they want. With this, we end this section, children. Thank you.